So good morning everyone. Our topic for today is on solving logarithmic equations and inequalities. So what are the difference between the three? Of course, logarithmic equation again involves an equation involving logarithms. So the symbol is an equal sign. Okay. For logarithmic inequality, it involves inequalities. Then logarithmic functions if it satisfies the definition. Okay, it's a function. So solving logarithmic equations and inequalities. So we have some strategies. First is we rewrite the given logarithmic equations into exponential form. Then we use the logarithmic properties or laws. Or we will use the one-to-one property, this one. Meaning, if they have the same base, this one, then u is equal to v. And another one is if we have these factors a, b equals 0, then of course either of them is 0. Okay, to understand this, let's have some example. Okay, number 1, letter A, find the value of x in the following equations. Now for number 1, take note they have the same base, log of something base 4. So by the one-to-one property of logarithm, this is for letter A, we can have 2x equals 10, right? By the one-to-one property, 2x is equal to 10. So solving for x is 5. Okay, substitute. Is this a solution? Log of 4, 2 times 5, this is 10. 4, so correct. So actually, there's no need to substitute fully. All we need to do is to check if this portion sa substitution is positive, because if it is positive, then the answer is correct, given that your solution here is also correct. Okay, so for number 1, the solution set is the set containing 5. Okay, letter B. How do we solve letter B? We cannot use one-to-one property because there is no log base 3 here. Okay, but we can use what? Transformation. I will transform this one to its exponential form. We can write this one as 3 squared. Okay, 3 squared equals 2x minus 1. Okay, this is our B, this is our A, this is our C. Diba, in exponential form, we have B raised to C equals A. So B, 3 raised to C, 2 equals A, 2x minus 1. So this is 9 equals 2x minus 1. 9 plus 1 equals 2x. So 10 is equal to 2x. Again, x is 5. Now, if you substitute 5, 2 times 5 minus 1, base 3. This is log of 9 base 3. So this is positive. And if you want to go on, log of 3 squared base 3. So property, this is 2, which is 2. Okay. Next. Let's have letter C. Again, we can use the transformation. So B, so base is x raised to C, 2 equals 16. Then take the square root on both sides. We have plus and minus 4. Okay, take note, x is a base. X is a base. And therefore, x must be positive. So our solution lang must be what? What must be our solution? I will write this, x equals plus and minus 4. Our solution only is x equals positive 4. So since we cannot have a negative base. Okay, letter D. This is addition, so we can apply multiplication. X plus 1 times x minus 1 equals 3. So we can have this one. If you multiply that one, we can have x squared minus 1. Right? Then from here, we do the transformation. We can transform this one to its exponential form. 2 raised to 3 equals x squared minus 1. Okay? 2 cubed is 8. X squared minus 1. So we have 8 plus 1 equals x squared. We have 9 equals x squared. Take the square roots. Plus and minus 3x. Now take note, if x is 3, so 3 plus 1, this is greater than 0. So defined. If x is 3 here, so 3 minus 1, that is 2, so greater than 0. So meaning 3 is a solution. Now how about if negative 3? If negative 3, so plus 1, this will become negative 2, which is less than 0, so not defined. So since this is not defined, we will not consider negative 3 as our solution set. So this will be our only answer. Solution set. Okay? Now let's move on. Letter E. So log of x squared equals 2. Take note that if it is not written, there is a 10 there. So transform to its exponential form. 10 squared is equal to x squared. Take the square root, plus and minus 10. Now, since that is x squared, if you substitute negative 10 or positive 10, x squared is always greater than 0. So if you take the log, it is always defined. Okay? So therefore, plus and minus 10 are our solutions. Basta defined lang yun siya. Okay? And last, medyo tricky ang last. Okay, we can rewrite this one as, take note, log of x. Let u be equal to log of x. Okay, so therefore we can rewrite this one as u squared plus 2u minus 3 equals 0. Okay, then factor out factors. They get the factors. U plus 3 times u minus 1 equals 0. So we have two equations, u plus 3 equals 0 or u minus 1 equals 0. And we'll go back to this one. Go back to this one. We have u equals negative 3, we have u equals 1. So the next step is this, go back to this one. U is log of x, p is equal to negative 3. So writing that one into exponential form, we have a 10 here, invisible, so we have 10 raised to negative 3 equals x. That is the first one. Next, log of x base 10 is equal to 1. So again, this is 10 raised to 1 x. Okay, so we have this. So if you substitute, both of them are positive. 10 raised to negative 3 is positive, so defined. 10 is also positive, so defined. So therefore these two are our solutions. Okay, the same lang na sila. Okay, let's go to solving logarithmic inequalities. So given the logarithmic expression log x base b, we have two conditions. So the same thing from the other topics, no? Pag inequalities, we have two conditions. Okay, so this one and this one. So x1 is less than x2 if and only if this is satisfied. So the direction of the inequality are opposite. No, the inequalities are opposite if it is between 0 to 1. But if it is greater than 1, so the same ang direction sa inequality. Okay, so let's start. So there's only 3. By the way, this is x. So letter A. So we have log of 2x minus 1 base 3 is greater than log of x plus 2 base 3. So we will not apply the our previous strategy for equation directly. No, first is step 1 is we need to know on what interval these two must be positive. So take note, log 2x minus 1 base 3 is defined if 2x minus 1 2x minus 1 is greater than 0, and the other one also is defined if x plus 2 is greater than 0. So meaning this must be x must be greater than 1/2 and x must be greater than negative 2. So if you draw that one, pwede ita nasi 1/2 3, negative 2 is here because it's smaller, so their intersection is where? This one. So from this one we will choose this, x must be greater than 1/2. Okay, because what happens if you choose x negative 2? If x is greater than negative 2 here, say for example there is a negative 1 there, right? If x is negative 1, substitute negative 1, we have negative 2. 2 times negative 1, negative 2, minus 1, negative 3. So this makes the expression undefined. Okay, that is why we need to get the intersection. Your x must be greater than 1/2. Okay, so that is step 1. Now what is step 2? Step 2 is by using our previous, no? This one. Okay. So our base, what is our base? Our base is 3, so greater than 1. So we will use this second part. So the direction is not changed. So meaning 2x minus 1 is greater than x plus 2. Okay, so solve for x. 2x minus x is greater than 2 plus 1. So we have x is greater than 3. So where is 3? 3 is here, right? So x must be greater than 3. So take the intersection of these three conditions. So therefore our final answer for this one is from 3 to positive infinity. Okay, so let's move to number 2. Number 2, log of x base 0.2 is greater than negative 3. Take note, we can rewrite negative 3 as log of 0.2 tapos 0.2 raised to negative 3, right? Recall the log of bx base b equals x. Okay, now here step 1 step 1, isa lang ang variable, so log of x is defined if x is greater than 0. Now let's go to step 2. Step 2 is since we can rewrite this one, no? x.2 is greater than log of 0.2 raised to negative 3. Since 0.2 is less than 1, so we will use this first condition so that the direction will change of the inequality. So this will come x is less than 0.2 raised to negative 3. So what is 0.2 raised to negative 3? 125. So x must be less than 125. Okay, so therefore if we have a number line, here is 0, here is 125, x is greater than 0, this part, x is less than 125, so this one. So where is their intersection? Kani. So strictly, so parenthesis, 0 to 125 is our final answer. Okay, and last, letter C. For letter C, the same with letter B, we can rewrite this one as what? So base 10, so log of 10 raised to negative 2, 10, log of x, and log of 10 raised to 2, base 10, and base 10 na. Okay, so we have two equations. So take note, 10 is greater than 1, so we can have this 10 raised to negative 2, the expression will the inequality will remain, so less than, and the other one, 10 is greater than 1, so we also have this 10 raised to square. So meaning if we have a number line, 10 raised to negative 2, what is that equal to? 0.01. So for example, we have 0.01 here, so less than x, so meaning the solutions are there on the right side up to infinity, and the other one is 100, x squared is 100, x is less than 100, so here to the left, so their intersection is this, right? So our final answer is 0.01 to 100. So this is our solution. And now you do your exercise.